As most people who start studying machine learning, I learned how to train a neural network to classify handwritten digits using the MNIST dataset. I was surprised to see how easy it is to reach 99% accuracy classifying images from the MNIST dataset. But I kept wondering, is there an interesting way to test its accuracy with other images? Alright, so this program is constantly looking for digits in the region of interest that I set on the screen, and to the right you can see another window that shows the same image after it has been processed in order to make it easier to feed it to the neural network. When a match is found, the program draws a bounding box around the digit, and it will show the percentage of confidence of that classification. So in this case, it's pretty confident that this is a 4. Here, it was able to correctly classify this as a 5. 8. In my experience so far, looks like 8 is really easy to classify, probably because of the very characteristic shape. Even when the image is tilted, is able to determine with a high confidence that it's an 8. Here it's an interesting case, 2 different ways to draw a 1, and for some reason it's struggling a bit with the one on the right, is less confident. So it could be because of the specific shape that is too close to a 7. Here I'm trying to classify multiple digits at once. 8, 3, 1, they all have been classified correctly with high level of confidence. Now let's try to classify even more digits. Here, 2 things to notice. The number 9 is being classified as a 4 with high level of confidence. That's a problem. On the good side, the number 5, even though it's incomplete, is being classified correctly. So in general, I've noticed this neural network struggles to classify the number 9 correctly, something I will have to look into. With this one, 100% confidence that it's a 6, but if we turn it upside down, it should say 9, but it's being classified as a 7. So again, for some reason it's struggling with this particular digit. So my first approach to the problem was to take the whole region of interest from the screen. Then I applied a blur and threshold operations just to isolate the number from the background and to eliminate noise. Then I apply an erosion operation to make the lines thicker. And then I run that image through a convolutional neural network that I trained previously in order to classify the image and identify the digit. Now, this worked fine for the most part and it's very straightforward. However, there is a problem. If the image to classify is in the corner of the region of interest, or if it's too far from the camera as shown here, then when I run it through the process, the neural network is unable to classify it. And that's because of the threshold operation. The threshold operation is great for getting rid of the background, but also creates this huge black area that was not present in the images that I used to train the neural network. So for an image classifier to be efficient and to work correctly, you need to feed it with images that are relatively similar to the images that were used for training. Now, for my second approach to this problem, I tried something different. I tried to look for cantors inside the image. So first, just as before, I captured the whole region of interest from the video feed. Then I run a blur and threshold operations, then an erosion operation. But then what I did was to identify inner contours inside the images, which most of the times correspond to the actual digit that I'm trying to classify. Then I took that isolated contour and I applied some padding to it just to make sure that the image is still a square before it's being fed to the neural network, since the images used to train the neural network were squares. And then in most of the cases, the neural network is able to give me a correct classification regardless of where the number is in the region of interest.